Going on now to topic 3 of chapter 3, the point slope form. And at this time on the top of the page, along with the title, should write the point slope form. Again, repetition. Let's start. Here are the objectives. And here's our introduction. So example 1 will be graphing a line given a point and a slope. So let's take a look at this. Just bring this down a little bit. Now there's our slope, and there's a point. Now for this, we'd like you to do some sketching initially. They'll give us a nice diagram down there below, but we want to build on what we know already. So we have a point that is 2, 5. So we're going to go over 1, 2 on our x-axis, and now we're going to go up 5. 1, 2, 3, 4, 5. So there's our point. Now, from this point, we know we have a slope of a negative 3/4. So, again, keeping in mind we have rise over run is our slope, and it's negative, so we're going to go over 4. So 1, 2, 3, 4 to about there, and that we do that mentally. And now we're going to go up 3. 1, 2, 3. So we can now make a line from this point through the point we already have, and in a sense, there's our right triangle. From that point, negative to the left, and then up 3. And we have created the graph just with one point and the slope. Now, in a sense, this relates to the other formula we've been using, y equals mx plus b, where we would plot the y-intercept first along the y-axis and then make that little triangle. Here, we're just creating a point somewhere, and from that point, making the right triangle. All right, let's take a look at what the book has here. So, again, there's our point. Now, instead of going over this way and then up, they went over this way and down. Again, giving you the alternative method for sketching a graph. But the key was to put that initial point and then making your right triangles. And there are a number of ways to do it. Once again, they're reviewing a couple of things. Up over here, there's standard form. There's slope-intercept form. There's the formula for slope. And now they're introducing, officially, since we've seen it a couple of times already, the point slope form, where you have one point and you have the slope. Okay. Now it's a little cluttered on this slide, so let's make it a little easier to follow. So for background, what we'd like to do now is take this one point and the slope, put it into the slope-intercept form. So pause, get this information down, and then we'll go through the process. And I'll change colors here. So we have the slope, which is a negative 3/4, putting our slope right there, substituting for that m. Now we have an x, and our first point here, our x-coordinate, and there's a negative in the formula, that negative there. We're going to put the 8, and then we have our y on this side. Again, a negative is in the formula, and we're going to enter our 3, which is our y value. So now we have successfully substituted our values into the point slope form. Now, the key is, what do we do with this? Well, we want to solve this equation for the letter y, to put this now into slope-intercept form. So with this fraction here, I'm going to suggest we're going to multiply each term by that lowest common denominator, 4. We want to get rid of fractions. So 4 times y is 4y. 4 times a negative 3 is a negative 12. Now here, 4 times this fraction, the 4's cancel out, and we're left now with just a negative 3 times x, which is a negative 3x, and a negative 3 times a negative 8 is a positive 24. Now we want to isolate the y, so we end up with 4y here. I'm going to transpose the negative 12 to the other side, where it becomes a positive 12. But we leave this here, 3x, negative 3x. Positive 12 makes this 36. Okay. Now, before we leave this stage, we could put this in standard form by taking this c term, I'll put it over here, and it would become 3x, transposing that, plus 4y equals 36. That's now in standard form. ax plus by equals c. Or if I divide now everything by 4, I get y equals a negative 3/4 x plus 9. And now this is in slope-intercept form. Y equals mx plus b. So these are the things we can do if we have one point and the slope. We can then put this into the point slope form. And since it's a fraction, I'm using that technique from an earlier chapter. We can then solve it for standard form or slope-intercept form. And there's, again, a lot of algebra here, but that's, of course, where we're moving. All right, now let's get back to our regular screen. And in detail, this is what they're showing on these pages. So again, introducing point slope form formally. Now, for example 2, you want to write that down. And then we have a slope of negative 1/2 and 1 point. And they want us to find the point slope form and then later the standard form. So we'll repeat what we just did and go to a white screen, again having some more room. And the formula y minus y sub 1 equals m times x minus x sub 1. And again, you're writing this repetition. So the first thing we want to do is substitute our values. So we get y minus 3 equals a negative 1/2 times x minus, from the formula, 2. Now, one of the kinds of examples they ask us to do in the future is if we have an equation that's in point-slope form, what is the slope? And then what is the ordered pair? That is that single point. Where you're looking at the formula, it's easy to pick out the slope. That's going to be a negative 1/2. But as you look at this, you see in the y position a negative 3. Now, is that the coordinate that we should put here? Negative 3. And the answer is no, because we know it was a positive 3. The negative came from the formula, so we have to be careful about that. The shortcut, it's always going to be the opposite sign of what you see for the y here. That will be a 3. And the opposite sign of what you see for the x, that will be a 2. Okay, now we want to solve for standard form from this. So let me get rid of this arrow here. And to get rid of the fraction 2, we're going to multiply everything by 2. So this is 2y minus 6. Now the 2's cancel out here, and we're left with a negative 1 times what's in the parenthesis. So that'll change the sign of what's in the parenthesis to a negative x, and this to a positive 2. Now we want to bring our negative 6 over to this side, and that becomes a positive 6 plus 2 is 8. We want to bring our negative x over to this side as a positive x plus 2y. And there's our standard form. Now, if we wanted to convert this one, let me write it again. 2y minus 6 equals a negative x plus 2 to slope-intercept form. Again, we're going to get the 2y, transpose our negative 6 to this side where it becomes a positive 6, so this is an 8. This is still a negative x. Now we're going to divide everything by 2. Keep in mind there's a 1 there. And then now this becomes y equals a negative 1/2 x plus 4. Okay. Now notice we have our slope as a negative 1/2. Well, it comes out here as a negative 1/2. We're in a sense just finding our new y-intercept. All right, let's see what they have in our textbook here. As we go back to this screen, and it looks a little funny. Let me clear this up too. And there we have it. Okay, now if we were to plot this, again, we would make our lines. And we're going to use the point they gave us, 2, 3. So 1, 2, 1, 2, 3. There's our point, and then a negative 1/2. So we go over 2, up 1, and that would be our graph, something like so. So it would be over 2, up 1. Now you could have gone over 2 this way, down 1, and there are various ways to do it. All right, let's go on. And there is our graph, keeping in mind that when we did it, we went over 2 this way, and we got up to this point. Now keep in mind, that's the y-intercept there, and this would be the x-intercept. We didn't use those. Let's go on. Now for some background, as we look at this slide, it says finding the equation of a line given 2 points. Well, here we'd have to, for example, 3. We have our 2 points. The first thing we'd have to do is to find the slope. So rather than my writing it out, we can just copy it from here, save us a little time. This was a technique we did in an earlier lesson. Now, the key is once you find the slope, and I'll pick up from there, and we're saying now the slope is a negative 4/5. We could use either of these points as our single point. So let's use this one. So we're going to go y minus the 2. Now remember, it looks like a negative 2, but it was actually a 2, the opposite side, equals a negative 4/5 for our slope times x. Now here it's a little tricky because there's a negative in the formula and a negative there. So this makes the opposite of a negative a positive 1. So again, picking out the points would be the opposite sign for the y, opposite sign for the x to give us this ordered pair. Now, we're just going to go for, let's say, standard form. And I'll change colors just to make it a little more. So we're going to multiply everything by 5 to get rid of that fraction. So this becomes 5y minus 10. Now the 5 is canceled out. That's why we did it this way. But we have a negative 4 times x is a negative 4x. A negative 4 times a positive 1 is a negative 4. So we're going to transpose the negative 4x to this side, where it becomes a positive 4x plus 5y. Transpose the negative 10 to this side, where it becomes a positive 10, and a negative 4 gives us 6. Now there is our standard form. And if we wanted to solve for y, we could take it from here, 5y, transpose this back to the other side, negative 4x minus 4, and I'll just divide everything by 5. So it would become y equals a negative 4/5 x minus 4/5. Okay. And as we look down the way here, we see this is what they've ended up with. Okay, now the book is also using the other point, and it comes out the same. So you can have a choice of points here that you use. All right, let's go on. See what in example 4, we're asked to look at a graph and then see if we can come up with an equation for that graph. Now, there are different ways to do it. For instance, you want to find a point on the grid line right there, and another point on the grid line right there. Now, you could find the ordered pairs, find the slope from the ordered pairs, and then develop your equation using what we've just done. Or just by triangulation, we could figure out our slope. And we'll do it that way. M is what? Our run is 1, 2, 3. And our rise is 1, 2, 3, 4. So there's our slope. Now, notice when it crosses the y-axis here, it's not on a grid line. So that's going to be a challenge. But we have our slope, and we're now going to have, let's say, this point. And this point is a -1. And it's up 1, 2, 3, 4, 5. So now, knowing the slope and one point, we can find out what our b value is, and we'll use our whiteboard for that. And we'll get rid of this part here. Okay. So let's use a traditional one here. Y equals mx plus b, because we just want to find out what our new b value would become. Now we know our slope is 4/3. We know our x is a -1. We know our y is a 5. And what we don't know is what our new b would become. So we'll change colors, and I want to get rid of that fraction. It's always easier without fractions. There's one term, two terms, three terms. I'm going to multiply each term by 3. So this now becomes 15. Here the 3's cancel out, so this becomes a -4. 4 times -1 is -4, and this becomes 3b. Remember, you have to multiply each term by that 3. So I'm going to add 4 to both sides. I get 19 equals 3b. Divide both sides by 3. So my new b is 19/3. So my equation in slope-intercept form will be y equals 4/3 x, and now this is my new b, plus 19/3. Well, again, this is not a whole number, so that's why the y-intercept was not on the grid. All right, let's check out what they have as we go back to our other screen and bring this down here. And lo and behold, they have it right here. And if you put this in standard form, again, you would multiply everything by 3 and then move your x term over to the other side. Now notice here they're showing the a term, that is the coefficient of x, as a negative. In a way that's acceptable, but often they don't want that first term to be negative. You would just multiply everything by a -1, and this would become 4x minus 3y equals a -19. That would be acceptable as well. Now, in this last part, they're introducing what are called parallel and perpendicular lines. And they're giving some review of things we've mentioned before, and I think it's a good idea to review. Y equals B is the equation of a horizontal line, and X equals A is the equation of a vertical line. Now, if lines are parallel, let's just get some background, and this is background, so take some notes on this. The slopes are going to be the same, 2x, 2x, but the y-intercepts will be different. Here, one is a -3 and one is a +1. So if the slopes are the same, once they're in slope-intercept form, and your y-intercepts are different, the lines are parallel. Well, how about for perpendicular? Now, as we look at the slopes, here this slope is 2/3, and this slope is a -3/2. Now, we had said that if we multiply the product of the slopes, and that equals a -1, one number being the negative reciprocal of the other, which gives you a -1 instead of a +1 if they both had the same sign, then these lines would be perpendicular and they form a right angle. So on our review sheet, we go over this, and again, a little review here. For example 5, we want to find an equation of a line parallel. Well, what they're giving us is an equation in standard form, and they want it to go through this point. So the first thing is you have to find what is the slope of this. Well, we're going to solve this equation, and we've done this before, for y. So once we have it in slope-intercept form, whatever's our slope, this will be the slope of a line parallel, and we want it to go through this point. Now we can use the point slope form for this, but we could also use the slope-intercept form. So let me illustrate that, and we'll show you the work. And I'll use the white screen for this. So we had done one like this, but we'll do some repetition. So we know our slope is a -5/3, and we know our x value is 3. We don't know what our new b will become, but we know our y value is 2. So we're going to get rid of our fractions by multiplying everything by 3. So this becomes 6 equals, here the 3's cancel out, and we get a -15. And 3 times b is plus 3b. So we now have 3b. Bring this over as a +15, and 6 is 21. So we're going to divide both sides by 3. And our new b now is 7. So we can write our equation in slope-intercept form. Y equals, we know our slope is going to be a 5/3 x. And our new b now is plus 7. Okay, hopefully you're getting some good notes and practice. I know this video is running a little long here. We're doing the best we can and going as fast as we can. And let's see what they have. And there it is right there. Y equals a negative 5/3 x plus 7. And they give you a nice graph of it as well. Okay, I think there's one more to do and we're... Now for our last example, example 6, we're asked to find a line of an equation that's perpendicular. Well, we're going to use the same equation and the same point, but now we want to find a line perpendicular. Well, if our original slope, once we found that out, was a negative 5/3, what would be the slope of a line perpendicular? Well, we said that one would be the opposite sign reciprocal, which is going to be a positive 3/5, because if you multiplied these together, they would give you a negative 1. Now we're still going to use our same point, 3, 2. Again, we'll go to a whiteboard and take a look at this and solve it. So again, y equals mx plus b. We know our new slope is going to be a positive 3/5, and then our x value is 3. Our y value is 2. And what we don't know is our new b value. So again, we're going to multiply everything here by 5 to get rid of that fraction. So this becomes a 10. 5's cancel out here, and this becomes a 9. And we have to do the 5 times b is 5b. Transpose this to the other side as a negative 9. This becomes 1. And we have 5b equals 1. Divide both sides by 5. We get b equals 1/5. So our new b value is going to be 1/5. So now we can write the equation of the line that's perpendicular. Our slope is 3/5 x plus 1/5. All right, let's check this out here. We want to keep this. We just want to get rid of our wipe screen. And there it is. And if we do the graph of it, it looks like this. Now, again, so often these new b's that we find, they're not on the grid, so they're fractions. But hopefully this gives you a protocol for solving similar problems. All right, this one ran over quite a bit, but lots of stuff.